Where was I? Oh yeah, with testing. Okay, so what we're talking about is just this transition from manual testing to automated testing. And automated testing can be as straightforward as in your script, you say at the end when you call your function, if function returns 2, then console log true. If function returns 7, console log true. So basically, you're saying if this function does this thing, I pass it these values and it gives me back this return, then I just want this nice little output in my console that says that this test passed or not, that I asserted that when this function returned a value, that it was this value and this value only when I gave it these parameters. Is that uh, did anyone think about testing that way, where you just kind of maybe add a bunch of different cases at the end of your file, and when you run on the command line, it just says yes, it passed, or no, it didn't? Anyone try that out? Probably didn't need to because we had Mocha and Chai. But before, students might have actually just done it that way instead. Maybe mentors would have instructed them to. But now with Mocha and Chai, if you include these tools, you can just use those and get that same benefit. And I know it's hard to write tests, but that's because we haven't gotten to the point where we are right now, which is let's learn how to actually think about the types of tests that we need to run and how do we write those given the tools that we have. So, why do we test? And like I said, you can't write software without testing. And the reason why we test, it's all about confidence. With confidence in our code, we'll actually continue to write more code. Uh, we won't get stuck writing the same code over and over or fixing the same bugs over and over. This is really great. This is a really freeing feeling as a developer to have this sort of confidence as you go forward that your code does what it's expected to do. And so I want to share, I guess, this path to confidence with you. And it's a pretty long path. There's a lot of learning involved. We're not going to be able to do it all today. This is, again, it's like I'm your tour guide. But over time, if you start to apply some of the techniques that I'm showing you today, you can start to build up confidence in your code, and you'll worry less about when you make changes. You won't be as concerned if it works or not because your tests will confirm that for you. And as a result, you're going to get better code out of it. So we talk a little bit about why testing, but then talk about strategic testing. How do we actually decide the types of tests that we should write and how we should apply testing to our project? We talk a little bit about test-driven development. So making sure we understand that sometimes it makes more sense for us to apply testing from the beginning before we write any code. And I'm not going to say that that's always the case because I don't always write tests before I write my code, but sometimes I do, and it's very useful for me to be able to do that when I want to. We'll talk about regression testing quickly. So this is my response to, well, I don't know what tests to write, and that's why I don't write tests. I'm not really sure where I should write tests. Well, let me tell you about regression testing, and then we can focus on using our tools, which is the next step, to actually write the tests that give us confidence, and we build up confidence over time. Okay. So the guiding principle that we're going to follow is, I'm not even going to read it to you. You can read this faster than I can. We want to test our software like we are the end user, like we're the person who's interacting with the project at the end of the day, because that's what we do when we're testing the software without automated tests. We click buttons and we fill in forms. We don't think about the internal implementation of our routes. We just think about, do they give us back the right HTML? Did they redirect us correctly? That's how we confirm that they work. And so we want to keep that mentality, and we want to take that into our automated testing, and we want to think about testing our software in a way that resembles how our software is used. And I'm going to split this up into tools versus testing. So we'll spend the second part talking about the specific tools that we're using in React to do React testing. But overall, when I talk about testing, these concepts can be applied to any project and any technologies. And the idea is is not to get too hung up on the specifics of what we're doing today, but think about how do I just, if I'm building maybe a Laravel project in PHP or I'm going into Ruby on Rails, can I take some of the same approaches in how I decide what to test and what constitutes a good test and how to confirm that the tests are good? Those are the types of things that you can transfer across different technologies. It's just the tools we learn that are different between them. So let's be clear that these are two things. And so strategic testing is the decision-making process that allows you to apply time to testing the right things, because it's unfair to expect that we're going to be able to have a 100% testing coverage. It's also unfair to any team to have 0% testing coverage. So that coverage of what gets tested, and I'm using the coverage term pretty loosely here and saying the amount of code that is run every time we make a commit, or before every time we make a commit, that amount of code should exist somewhere between 0 and 100% of it is tested. But it's not the same for every project. So a test strategy is about deciding for your project how you apply testing to gain confidence. And this is the hard part. This is making these decisions it takes experience. And we're not going to understand all of this coming out of it, but I want you to take the experience I have and try and apply as much of it as you can. And we have these shapes here, and these shapes are interesting ways to talk about test strategies. Can anyone tell me about the first shape on the screen? Why is that there? I'm looking at chat too now. I'm trying to do a better job at looking at chat. Top down. Oh, top down. Okay. Top down approach to testing. So what we're thinking about is or bottom up. I mean, at the end of the day, I guess top down or bottom up, this is your strategy. So it's more about maybe the quantity of each type of test that you have. So let's say a test strategy could include different types of testing. We've got unit testing and integration testing and static analysis like lint. And we've got end-to-end testing. Okay, focus more on unit testing, right? So you might say at the bottom is static analysis. Let's statically analyze our code using ESLint, and then and maybe TypeScript would be another way to do that. Okay, this is a good way. So Henry's saying focus more on unit testing. That's part of it, but it's more of the less costly tests and less of the costly tests. So that's a hard thing for me to read and say at the same time. What we're saying here is at the bottom we'll have static testing because that's pretty cheap to do. If we implement ESLint and TypeScript, then we're adding, as we add code, we're kind of writing the tests in there because we're giving things types and we're also making sure that our lint passes before we commit code. And then the next layer up would be unit tests. So they're pretty easy to write because you tend to write unit tests on pure functions, and pure functions have no side effects, which make them a lot easier to test. Then you've got integration testing on the next layer, and you might write fewer of those than unit tests because they're more expensive to write, but they will test the integration of multiple units together. So make sure that my billing and my user profile works together by making sure that when I charge a user, their account is the one that's charged. Like that, that's an integration maybe between two systems where I can confirm, one, that the billing goes through, and two, I can confirm that something happens with the user, but I might need to write a test that confirms those things work together. And at the very top, and maybe this is, I don't know, who knows, but there's like 5 layers here. It doesn't really matter. The point is, at the very top of your pyramid are the costly end-to-end tests, the ones that have to be rewritten and maintained more. They cost more to write at the beginning potentially. But the idea there is let's just write the stuff as tests. Or maybe for me, the approach is if I was going to do that type of thing manually, so let's say for Tweeter, my test would be load up the app, type in a tweet, press the submit button, and confirm that tweet shows up in the page, and then drop the thing down, and then or show and hide the compose thing, or whatever the different requirements are, I might include that in a test that I run every time I commit. And it might take a little bit of time to write that test because it has a lot of steps in it, but it allows me to run it in the same way across a whole team every time my code is changed, which is actually quite a big benefit. So end-to-end tests are quite useful for that reason. But then we have this idea of this pyramid, which is just a different strategy, right? So with the different strategy, the pyramid says write mostly integration tests because those are the ones that find most of the problems. And you can do you want to do static analysis, you want to do unit testing, you want to do end-to-end testing, but really this big fat part up here in the pyramid, or sorry, in the trophy, is the integration tests. Do I buy into that? I think with React, yes. With React, I take this trophy approach, whereas I think with a pyramid, or with Ruby on Rails, I might take more of a pyramid approach. Or maybe now that Cypress exists, I might write more end-to-end tests because that's become a lot easier. These strategies are going to change. That's why for every project, it's going to be different. And that's why I'm trying to tell you that I can't just give you one strategy, follow it. It's more about understanding there's all different types of things we can do and applying those things, hopefully, on your own. There is no teapot strategy that I'm aware of, but if there was, I'm sure it would be about, write code that flows into a saucer or something like that. I don't know. So here's a goal of mine. Who wants to join me? Yeah, sounds great, right? And it's possible. So this book here, Test-Driven Development by Example. This one's my copy. I think maybe if it's close to my face, it's not as blurry. And it is a good reference. I'm not actually going to go and suggest that everyone buys this book. Although feel free, if you do, it's worth it. You can also find copies. I've found copies before. But what I did do was transcribe the preface and this section about courage for you. So I took this right out of the book, and I just transcribed it for you so you could read this section because I think it's actually quite an interesting read, and I wanted to share it with you. So I hope that you go into the docs section here of the notes, and in the docs section there is a TDD markdown that really just has like that, literally what's in this book on the preface. Okay. And in it, it's really nice because it talks about just a little bit about what test-driven development is and why we do it. I think it's quite motivating. And so here, I'm going to share with you the rules, the basics of test-driven development from that section. So if we follow these rules, then we are doing test-driven development by definition. Rule number 1 is only write code if a test fails. So you read that. And here it says minimal code necessary to pass the test. Okay, so that's also an important step. And then step number 2 is eliminate duplication. And let me share with you what that looks like in practice. Here we are. Here's my test. So I can't write code until I have a failing test. So the first thing I have to do is write a test that fails. The first reason this test is going to fail is because there's no function called add. So if I add a function called add, then it's going to fail because it doesn't return anything. And then if I fill in the details of the add function and it returns 2, then this test passes. Does that make sense? So now my test passes. Okay, write the minimal amount of code to make this test pass. If we actually think about this literally, and I want you to because I think that's important. If I think about this literally, then this happens to be the minimal amount of code to make this test pass, right? So if you write a bad test, then you will write bad code if you follow the rules. But that's really good because you want to write good tests, right? So in order to encourage you to write good tests, like this one, then we say write the minimal amount of code and then you can't, and don't cheat yourself, right? So here, I can't write this code anymore because in order to make these tests all pass, this code has to be implemented in a way that add actually does what it's meant to do. Whereas if I just write a test that looks like this, then yes, I've tested that if I pass this 1 and 1, this returns 2, but it doesn't necessarily take into account that returning 2 is simply, I can just return that if I want. So write good tests. That means think about edge cases, right? I actually have another lecture on testing I think it's actually a different one. So this is an older Ruby one, but since we moved the content, here we go. This is how good testers think. They don't just think about what the good case is and move on to the next feature. They think about all the possibilities that a user might do, and they break the thing, and then they tell you it's broken. So as developers, we can also break the thing and tell ourselves it's broken and then fix it, right? So we want to have this mentality as we're going into it that says we write some good tests. We think about all of those edge cases, like if we pass in the lizard or negative numbers or whatever, and we write tests that reflect that thinking, and we write good working code that we have confidence that works. Make sense? Okay. So this is a red-green refactor. It's a process. It's described this way as a process in the book. And a process tends to look like this, right? Where you start with red, and then you go to green, you refactor. Now you're back to red until it's green again, and you kind of the next step here is to eliminate the duplication. So once you have working code, then go through your code and eliminate duplication to make it easier to work with. So this is kind of a maintenance step built into the process. And you use the tests that you built to confirm that the code continues to work. So the reason we write the minimal code necessary to make sure it works is let's just get a passing test. We have a passing test, we can refactor that code and confirm that it still works. This is how I write a lot of my code once I have tests. I feel way more confident refactoring after I have tests. Sometimes there's no time, but if I have the choice, I will definitely write tests before refactoring. This is the way I see the process. I see it as a way forward, not necessarily just a loop. And the analogy that they use in the book is one where the difference between bringing up two different sized buckets from a well. And so if I have a small bucket full of water in a well and I just have a crank, I could probably crank the whole thing up without getting tired. But let's say I have a really big bucket of water, and to crank the whole thing up, I need to spend a lot of time and energy and effort. Well, it'd be a lot easier if my crank had teeth, because then it would just stop and not go backwards every time I did a crank. And that's what it's saying tests are like. The tests you write in test-driven development are like the teeth in this crank, and that you don't actually lose progress because you have code or tests essentially that confirm your code still works the way that it always has meant to be working. So I like their analogy. I definitely recommend going to read that couple paragraphs about it. TDD is not all or nothing. Don't let anyone tell you it is. This is where people, I think, lose. Everyone loses when we start thinking TDD is all or nothing. Use it when it makes sense. And you're going to have to figure out when it makes sense, but first you have to know how it works, right? And if you want more concrete examples, we could talk more in detail about how I apply it. And I'm going to even try during the example today to show you a little bit of TDD. Okay. So any questions on TDD? I'll go back if we have to. Let's keep moving. What is regression testing? This one I'd actually like an answer to from the cohort. What is regression in the context of software development? Oh, make sure bugs from previous issues don't show up in any further versions of the code, rerunning functional and non-functional tests. Yeah, I would say, so Sarah's good answer. Make sure bugs from previous issues don't show up in any further version of the code. That's correct. And rerunning functions and non-functional tests, that is a way that we do regression testing. So, Hannah, that would be an application, a way to actually apply a regression process would be through the continuous running of functional and non-functional tests. That would be, yeah, that's a good way to put it. So, both correct in the sense that they're both related to this process of regression testing, and so progress is moving, let's say, moving forward. So regress is to move backwards, and regression testing is to confirm that your code does not go backwards in its functionality. So I'm going to share from the actual activity here, or from the notes. When I was preparing this, I actually happened to read this blog post. And it says here, how to uncover a 0 day in 4 hours or less. So this is a 0 day is a 0 day exploit, one that is not really, is not publicly known in software. For example, iOS software, they have exploits that can be used to jailbreak the software. So these are obviously bugs in the software. So this person wrote this article, and it's really interesting, except I don't expect anyone here to actually go read this. If you're interested in this kind of stuff, go for it. But I wanted to actually talk about this in terms of how we apply testing and how that is important. So, great article, but really it's only here. At 3 o'clock, the Uncover jailbreak was released for iOS 13.5. Using a 0 day vulnerability and heavy obfuscation. So this is basically how they uncovered, or when they did it. So here's this journey that they're going through. Now, the only thing that really matters in our context is the summary down here. So this is what they say at the end. I know you're probably reading this now. So all this person had to do was take issues that had existed before and retest them against the latest software to confirm that those issues existed again, and then they would apply an exploit to those issues again in that latest version of the software, and in this case, I think release a jailbreak is how it happened. So this is real world regression testing, and if Apple had tested for regression on these features in their software, so tested that sock puppet doesn't exist anymore, and tested that Lightspeed doesn't exist anymore, and these are exploits that existed previously, then they wouldn't have had this problem in the first place. So this is a real world good example of this happening. Okay. So any questions about regression testing? Okay. So when I said I'd talk about this quickly, the reason I wanted to bring this up is because my recommendation is, if you do not know what to write tests for, then wait until you find a bug. Because if you wait till you find a bug, then you know about a bug and you know what to write an automated test for, because you just need to write a test that confirms that bug doesn't exist. So you have to understand why that bug exists in the first place. And then you have to write a test that confirms it doesn't exist anymore. Now you have regression, because if you run that test before every commit, you will confirm that bug doesn't exist anymore, and you will start to build up a test suite of regression tests, and that is a great way to start. So if you don't know how to start writing tests that confirm bugs that you found manually don't exist anymore. Okay, lots of different tools. I'm going to have to blast through this stuff, but we're going to use these tools in the live coding, so you can ask questions then as well. The main thing is that we know the different purposes of these tools and why there are so many of them. So the first one, we'll talk about Jest. We're going to talk about the testing library suite of tools. It's more than just one tool. Oh yeah, great. Let's do a break. 10:30 sounds good. I'll leave it here, and let's come back at 10:40 and keep going at that point. All right. What we were talking about. So we made the transition from like test strategy. Now we're going to talk more specifically about tools, and then we'll live code some tests. So the test runner that we're going to use today is called Jest. The test runner that you've been using all week is called Jest. So this is not going to be your first time using it. You haven't written a lot of tests, but you have run a lot of tests making this project. And so, so Jest is like Mocha. It manages the reporting for whether or not tests are returned successful or not. And it's a good test runner. It also manages coverage and that kind of stuff. So this will be the framework we use for testing. And since we're doing React testing, we also want to add some helpers that make it easier on us to test both DOM elements and specifically React components. And so that's why we're going to include this helper library or suite of libraries called the testing library that includes multiple libraries for specific purposes. So our test runner is Jest. For matchers, we're going to use Jest and something called Jest DOM. For utilities, we're going to use the DOM testing library, the React hooks testing library, and the React testing library. For mocking, we'll use Jest, and for test coverage reporting, we'll use Jest as well. So this is what the test runner looks like. This is it reporting back. Here are the tests. Here are the ones being run, etc. Should look pretty familiar. Most test runners look similar to this. And Jest provides this functionality to us. If we set up Jest and we run Jest, it'll go through and look for certain files that match certain names. We can see that here. Things in __ tests folders or things that have a .test in their name, they'll get picked up. And if they have a format like this, then we can describe a group of tests, and each of those tests will test something. We can use it, and we can also use, I think, test, although I never do. So let's say instead of it, you can use test. I just like to use it because I like to give the string it should do something. That's what the result of this test should be. So that's why I tend to stick with it. You can also skip your tests. So if you don't want to run this test that was defined with it, you can skip it by putting X in front of it. If you use the test word instead, you would do test.skip. This is if I was using the test keyword instead. I could say test.skip to skip this. So here it describes what the test is there for. 2 + 2 is 4. And then it runs the code, and it allows us to use things called matchers. And so here it's saying that we expect that when we take these two values together and add them, that the result of this operation is going to be the number 4. So this is the matcher. When I said that we're going to use Jest and Jest and Jest DOM as matchers, Jest provides built-in matchers, but in order for us to test the DOM specifically, which Jest doesn't actually care about, we use the custom Jest DOM matchers to help us with this. And so things like we expect an element on the screen to be disabled, or we expect an element, these are DOM elements, to be in the document, or to have a value, or to be checked. Those are things we can use the Jest DOM library. Again, that's why we have all these things here, so that we get these different capabilities. Makes it easier for us. We don't have to write all this code ourselves. And we can use these matchers to confirm that certain elements are showing up in the DOM properly. And these tools here are going to allow us to do things like render components. So for example, Jest doesn't know how to render a React component. So we need to make sure we know how to render a React component. The React testing library is going to allow us to do that. There is also a Vue testing library and an Angular testing library. And all these three libraries are built on the DOM testing library because all of these are DOM manipulation libraries. React, Vue, and Angular, they call them front-end libraries. But they're there to help us manipulate the DOM in a declarative way. So the DOM testing library lives underneath that, and we can use it to test anything on the DOM that we want. So that's why I'm kind of going over what are all these things that we have to use? Where do our tools come from? Well, they have APIs, and the APIs are well documented, but I'm going to share with you some of the things and where they come from. So I guess here, the DOM library, if I want to get something in the DOM, then I could get all the elements by the text they contain and provide a certain type of text, like a name or something like that. I can get just the thing with label text. So get by label text, get by title, get all by role, query by title. I'm not going to get into the details right now about the difference here of these, query and find and get. Mainly we'll be using get and query, but there is a major difference between get and get all. I think that we can all kind of understand. Okay, so get all by text will allow us to find something on the page. That's how we can confirm that that the thing passed the test. And what's cool about these is they actually match only things that are really about our reality as users. So when we say that we want to test in the way that the user interacts with our application, these are different. This API lives by those rules. And so I want to make sure, and I want to draw attention to the testing library docs, and specifically under recipes, there's a thing that says which query should I use. When it says which query should I use, it means which combination of these queries and variants should I use. So this is what I would point you to in order to make those decisions. And they say the priority is based on those guiding principles. Where did these come from? The more you test, the more your tests resemble the way your software is used, the more confidence they can give you. So this is our guiding principle, and it says if we follow these rules, then we can have that principle and live by it. And so the first sets of queries we want to use are things like get by role, get by label text, get by placeholder text, get by text, get by display value. And these are queries that are accessible to everyone. So mouse users, visual mouse users, as well as those with assistive technology. This is a way to test in a way that's accessible as well. If one of these doesn't work for you, then you can start to do things like get by alt text or get by title. And these would be things that the user doesn't necessarily see, because in the case of alt text, they actually see an image instead, but a screen reader might read the alt text. And so these things are also all right to be used for testing. Even though they're not visual, we get by on that. And so if I need to click on a button that is only an image, like you will have to do, then I might get by alt text and find that image that is the create button or the trash button or something like that. And the last resort, if we can't use one of these queries, then we'll get by test ID. And that means applying a specific ID for testing to an element in the DOM that we can refer to later if we want. Okay. So that's about the queries. Here we go with React. The React testing library provides things like rendering a component, cleaning up after a component, or act, which means how do we handle side effects, things that take time, like API calls. If we wrap the thing that changes the component in an act call, it will wait for that to happen. So this is about asynchronous tests. I won't get too deep into that right now. We do have to talk a little bit about mocking. And there's mocking kind of broken into two stages. One is I want to be able to spy on a function that I create and see whether or not it gets called or not. And two would be I want to actually change the implementation of a function. And you're going to do some of that mocking. You're going to make your Axios requests always return hard-coded data. They're not going to even bother making the request to the API server eventually. So here in this example, I'm creating a new function called mock. I create that function using jest.fn. That's creating a new mock function. And I expect that mock to have been called 0 times at this point. But if my code runs that mock function, then I would expect the mock to have been called the number of times I would expect my code to call it. So this is a way to kind of see whether or not our code is calling our callbacks, for example. We've also got this concept of coverage, so we can actually test to see how many lines of code are actually tested, are run through our tests. We're going to use this to help guide which tests we write, and we're not really focused on just making sure that the coverage exists. We're more curious about what code gets run, and we can figure out if code isn't being run and think about, okay, well, what tests should we write that are good that also run this code, not just what tests could we write that run this code. So we don't want to get too trapped into the coverage game and say, because 100% is not the best coverage if it's bad, if it's a bunch of bad tests. 75% where the tests are really good is way better in my opinion in terms of confidence levels. All right. I've left it open to questions the whole time, so this kind of is one more cue here, and I think I can switch over to the live demo now. We took a break half an hour ago. We will take another break in a half hour, but let's, I think, get started coding if there aren't any questions right now. Okay. So I'm going to clone this project. Oh. And this project should be working in a working state. I'll just double check that by going into it. I'll install the dependencies first. This will take a second. You know, I've been using Yarn lately for a project, and it feels like it's faster. Now I have to actually measure that on the same project to see. Because I haven't had a good reason to use Yarn yet. Yeah, it's like I haven't run npm install since running Yarn install, and this is so slow. Could just be that I built the app using Create React App, which adds so many packages. All right. I gotta just run it. It'll open up the server for me. That's fantastic. Okay. So this thing's loading, and there's a loading state. Actually, it's not really real. It's just a timer. But the whole idea is that we want to see how loading states work when we're testing things, because I have to wait for this to load before I can start testing it. So I have to make sure that, you know, something like this shows up first. So that's kind of why we have a loading state in this app. The app idea comes from something like this. I don't know if anyone's familiar, or if everyone's familiar, maybe not. It's this game where you make cookies. And when I make a certain number of cookies, I can buy a cursor that clicks on the cookie, and it now creates 0.1 cookies per second. And so if I click again and make more cookies, I can use that to buy another cursor, and the cost of the cursor goes up every time I buy one. So it becomes more expensive, but my cursors are helping me out. So 4 or 5 days later, you just got a whole bunch of stuff. Grandma's baking cookies. Let's see if we can get to 100. Anyways, the whole idea is you're clicking on this thing and it is changing the counters, and then also there's a timer that's also updating that counter at a certain rate as well. There's also paperclip factory. Make a paperclip. Raise the price maybe a little bit. I don't know. I gotta get money. Yeah, here I got $1. When I get a certain amount of money, I can increase my marketing level. I'll sell more. I think I'll sell it for more money, or I'll sell more clips. But the idea is just clicking on these buttons to get to the point where I get to auto clippers, and with the auto clippers, let's see. Now it starts to automatically make clips for me. So again, a timer and a button click to increase at the same time. So this one's a little bit simpler. I can add bugs, and when I fix a certain number of bugs, I can use those bugs to buy tools that fix bugs per second. So here, if I now leave it without touching it, we can see I'm fixing 5 bugs per second. And if I add a new bug, it adds it, but it still just adds 5 a second. So this app has a few different pieces. The first thing on the index, kind of take a look at this. Not much here. Just import an application, render it to our DOM. In the application, we have 2 custom hooks. So the question in the chat was, use reducer, or let's see. Oh, wait, no. Difference between a custom hook and a helper function, right? So these custom hooks, the reason why these are hooks to me is because they use hooks inside of them. So use bug tracker, it has use state, and it has use callback, and these are hooks provided by React. So therefore, this uses a hook. Therefore, it must be a custom hook, because we can only use hooks inside of components. So we need to make sure that we only call these within components. So the reason why we put use in front of it is just as a signifier that says this should only be called within a component. So here, when we call use bug tracker, it returns 3 things to us: the number of bugs, something that allows us to add a bug, and something that allows us to remove a bug. Again, all that state is being managed through a set state call. When we add a bug, it takes the previous value and adds that amount to it. And when we remove a bug, it takes the previous value and adds to it, or removes from it. So it looks like add and remove bug taken a number. We can either add or remove 1 bug or 20. One of the greatest things about custom hooks, and I think a lot of people say custom hooks are great because we can reuse them in multiple components, that we can reuse and share functionality between components. But I would say one of the greatest things about custom hooks is that they actually allow us to hide a lot of complexity behind a simple interface. That instead of thinking about all of this stuff here in my component, I can think about that and limit it to my hook, and think about it only in terms of, well, I just care about the bugs and the functions that allow me to change those things. And however those actually happen, the details are hidden within my hook. And I could use this in other components if I wanted to, no problem. But to me, this interface, making it simple and not having to worry about these ugly details of Very powerful. Our use autofix actually takes in a dependency. It has a dependency. It needs to have a function that knows how to add bugs because our autofixer will, over time, increase the bug count. So use autofix. That's a hook as well. It keeps track of state. It also has some side effects. Let's not get into the details of this hook. We don't even need to know the implementation details to be able to test it, because we're going to test like we're the end user. So this does use hooks. Therefore, it also has to be a custom a hook. But all it does is give us two things. The current, can I explain the use callback hook? I think I'm going to have to leave that out of this lecture because it's not important. It was left out of the React curriculum because it's a more advanced feature. You will need to use it, but yeah, I unfortunately can't spend the time right now, Sergey. It's but afterwards, it's something we could talk about. But there is a reason why it is not included in the material up until now. And it's really just an extension of the use memo hook. And use memo is a way for us to cache values across renders. And we haven't needed to do that yet. So I don't want to get too deep into that. Even though I'm using it here, I'm using this to show you that we don't actually need to know how this works in order to test it. And that's actually one of the nice things. If someone gave you this hook and said, well, pass it a function that knows how to add bugs so that every time it hits that timer, it adds that, it knows how to add the bugs. And also give us back a function that knows how to increase the rate, because that's going to be happening every time we create an upgrade, we're going to increase the bugs per second. We also need to keep track of our upgrades, but I don't necessarily need a hook for that. Maybe I'll just do that here. When they're loaded, so they're loading right now by default, and when they're loaded, they'll have data. So here we'll start off a use effect. We'll get the upgrades by calling some API, maybe. Who knows what this function does? All I know is it's asynchronous because I've attached a then call to it. So this returns a promise. When the promise is resolved, I want to take the upgrades that are returned to me from the API and set them as my upgrade data. And then also set the loading state to false. So that's what's happening initially. When I refresh this, loading, set state, loading false, and with a list of the upgrades that we now have access to. If the upgrades are loading, then return a loading tag in the div. Otherwise, return the app because we have the upgrade data that the app depends on. We can't actually do this with a map until things are loaded, right? And actually, I guess what we could do is say by default, data defaults to empty array. And then here, we don't have a loading screen. This would be a way to also make this app still work, but no upgrades until they actually come in, right? That's actually kind of nice. A little progressive download. Maybe we actually say here is where we have to actually check the loading. I'm going to keep that because it's, I don't know, kind of cool. So what I've done here is I've just changed. Let's see. Close. So now I've moved that loading indicator down here because that's actually the data that depends on it. Everything else doesn't care. Like I can start to use this app. And when it finally loads, oh, I have enough, I can do it. So I can manage all that. It's kind of up to you. Okay. But this is roughly how the app works. And I'm going to go back to my example because this is what I really want to do to show you waiting for loading to complete before we run anything else in a test. But we'll get to that when we do asynchronous stuff. This is going to show the status. So status component takes in bugs and a bugs per second and it renders it out. That is That's this part here. That's my status. If I load up the component viewer here, I can see status is just this part. Bug is right here, and bug takes in an on-click event, whereas status takes in BPS and the bugs. See, that's constantly changing. So this status component keeps re-rendering every time it gets a new number of bugs. We've got the upgrades, which is a list, but actually our application has that state right here. These are the upgrades, the label, console.log, the cost, 10, and then how many it adds in terms of our bugs per second. So all this data comes from that API call. It's stored as state, and then it's passed down into the upgrades component right here. It's passing down the upgrades as children. The number of bugs is increasing. The reason, could someone tell me why right now the upgrades component has to have access to the bugs? Why do we think that that this upgrades component needs to know how many bugs there are currently? And why is that? And that value keeps changing. And every time that changes, the upgrades now has the latest value. There's a clue. It just happened when these things activate. So these two activated when this hit 100. So the reason why we need to pass these in is because the upgrades needs to know whether or not I can actually afford the upgrade or not. So we're passing down the number of bugs because inside of upgrades, it is disabled if the bug count is less than the cost of that element. Okay. There's some stuff going on in here. Again, it's advanced, but this is not a React lecture. This is a testing lecture. So I'm going to leave some of this advanced stuff unexplained, but just know disabled, it is dependent on whether or not you have enough bugs to pay for that upgrade or not. And the upgrade costs $10, $100, or $500, or $1,000 bugs. Okay. So I know I've kind of gone through that quickly. My process is going to be to go over some of these tests first and then rewrite them, because I think it's actually good to see them and then rewrite them after. But do we have any questions about this app and these components? I mean, this one's quite straightforward. The bug one is just a button. Is there anything anyone wants me to show before I move on to writing a test for this? Okay. I'll take that as positive feedback, I guess. So if I go into my project, I can npm test. And this is starting up Jest. And no tests found related to the changes. So it's actually pretty smart because it only wants to test some files, ones that have changed. None of my files have changed, but I'm going to hit A to run all the tests. And so that's what's happening now. And all my tests are passing right now. I've got 17 tests that have passed, broken up into 8 different test suites. It took me 8 seconds to run that test, but they all passed. We can see the naming structure follows what we did for interview scheduler. We put folders called __ tests to keep our tests separate from the files. You could also do it this way. Put them next to each other and then not have this test folder. It's kind of up to you. If that's the case, they must say .test if they're going to be, obviously. They have to have some sort of way to identify them individually. But I can go look at these now. And one of the tests that I might want to write is just for this status component. So let's say my status component, which is what I'm describing a test suite for. That's where this. Oh, let's rerun that again. I think it got lost because I moved the file while this was running, and then I moved it back. So I'm going to just make sure it passes first before I go forward. Okay, good. So out of these 8 suites, one of them is the status component test suite. And the status component should render the current status. Okay. What about, like, this is a unit test for this component. I'd consider this to be a unit test for this component because we pass in some values and then we check to see whether or not certain data is on the screen. And we can see that's actually just testing that this is what we'd expect it to see, expect rendered. But we can even go further than that and say, well, what about in this formatter? So I actually have this helper function that's being used inside of my status here. And my status is pretty straightforward because what it does is it takes format current bugs and it calls it with the value and it just displays whatever this function returns. Is this similar to something we've done already? Can someone in the chat or even in voice just tell me where they've seen this idea before? Formatting spots, exactly, yeah. So with formatting spots, there were 3 options. It could either say you have 0, or no spots remaining. You have 1 spot remaining, or you have 2 spots remaining. Right? So same idea here. This is the exact same concept. I've decided that this message does depend on the value here, that the English language and pluralization is important in a user interface, but I don't want this logic to be in my component because that's just, like, imagine if I had to put those 2 functions in here, this file automatically becomes unnecessarily complex. So instead what I do is I create these helper functions that have a single responsibility. They take in a number of bugs in this case and give me back a formatted string. And this one does the same thing, but with bugs per second. And so if I want to test the functionality of these right here, then I don't think the right place to do that necessarily is here where I say it should render the current status with plural. So now I'm testing that pluralization in here. And now I have to do all of this stuff and say, if I pass in 2, and it does 2 bugs and 2. This is not the correct place. In my opinion, this is not where I want to do this testing. I'm going to actually be clear about taking that back. I don't want to say not the correct place. I think it's not it's not the place that I like to do it because I think that there's a more specific place to do this. I can leave this test here because this is actually checking to see whether or not when this component renders, it shows both of these things. So that's a bit of an integration test of these 2 functions. It's actually testing the integration point of these 2 functions. But what I would do instead of writing this specific test here is I would have a unit test like this, and this is where my formatting test exists, right? Because this is where I can do all the edge cases for that function, and that function is really easy for me to think about, and like what goes in and what comes out, and I don't even have to think about components. So I would do a full unit test for this utility function in its own file with all the edge cases, so that when it comes to testing the status component, I feel confident that my edge cases are tested for the pluralization issues and all of that. And so now all I have to do is test that this component does what it's supposed to, which is render the result of those functions. So if I give it a 1 and a 1, I do have to make an assumption, I do know what it's going to return through those functions. But here I'm not testing those functions anymore. I've done that already. I did it here. And so this test is just about or the status test is just about confirming that this component works. Is that clear to people, that the difference and why we might choose to put unit tests here for something like this? Whereas even though we could do all that testing for all that functionality in this set of tests instead. Cool. Okay. So if that's the case, let's write this test up and see what it should do. Make it fail. There we go. So it passes, and right now I already have the code for this, so I can't really follow test-driven development, but I will do one test-driven. But let's do this one not test-driven first. So status is going to render these tags. I actually don't necessarily care that they're H2 and H3. Maybe I care about the order they're in, but let's keep this super simple and just say that I care that both the things that are meant to be rendered do get rendered by this component. So I expect that something, and that thing that I have to expect happens to be a DOM node. So that's what I need to do first. I need to render this component, and then I need to find a DOM node somewhere on the screen, and then I need to confirm that it has a certain text in it. Because that's what I would do with my eyes. Right? If I'm going back here, I would come here and I would say, by default, this should be 0 and, well, you have not fixed bugs and no auto fixing. As soon as I fix one bug, it should say you have fixed one bug. I'm doing that with my eyes. Therefore, I'm going to look for that DOM node and check its text. We can render any component using the React Testing library. The React Testing library. It provides a render function that it exports. So this is, again, this is in the notes and in your examples already. But this is where the render function comes for, specifically the React Testing library, not the DOM testing library, because it's about rendering React components. And this is going to return a bunch of different stuff. This render call is going to return an object with a bunch of functions on it. One of those functions is get by text. So the React library is actually making available to us all of the DOM testing library functions this way. This is how we actually access them. And the thing we want to render is status. And if we want, we can also debug this, because the render can return a debug, and we can see what does this actually look like in the DOM. So because of this debug call, I'm not doing any assertions or any expect calls here, but I can output this and say, oh, this is what happens when I call status with no props. It says you have fixed undefined bugs and fixing undefined bugs per second. So that actually might trigger something in my mind that says, I should probably handle that and set up some defaults for this. Maybe the default should be 0, right? But we're writing a test for this, and what I need to do is say bugs is equal to 1 and BPS is equal to 1. And so now when I run this test again, this is what I would expect when I render this component. So my getByText function is going to search all of the DOM nodes and look for anything that has the text, you have fixed one bug. So I'm going to search the entire DOM for something that has the text, you have fixed one bug. This is going to find this H2 here. To be in the document. That's all I care about right now for this test, is that something with this text exactly exists in the document. And I can do the same thing. Run this, and now my test should pass. And then the process is like, well, make sure that this actually works. Okay, well, what if I change this to 2? It shouldn't work anymore. It should fail. So I'll test that first and make sure my test is doing what I expect it to. Ah, good. It failed, and it said it's unable to find the element with the text fixing 2 bugs per second. And look what it did. It actually printed out that same debug information to me. You'll notice I removed the debug call. I'll get rid of it completely. And it outputs it when there's a failure. So you can kind of go and look and see what is the state of my DOM right now. You know what? I like to upgrade this a little bit. It should render the current status even without props. So get rid of those props and say you have fixed 0, or you have, let's see, I forget exactly what it was. It's okay, I can just check my tests. You have not fixed any bugs. Okay. So this is what I want to say when there are no props. No, what is it again? No auto fixing. So I'll run this test, and this is actually getting into a hybrid test-driven development mode, because now I'm writing code for a feature that doesn't work, right? This is now, I've written a test that fails first before I write new code. So now in order to make this test pass, I can go into my status component, and I can say that the bug default is 0, and the bugs per second is 0. And when I do that, now my test passed again. And I feel more confident my code is better because I identified that issue, that if I don't pass props in, that it shows undefined. I don't want undefined in my UI. So I should probably handle that case and then make sure there's a test that confirms that no one goes and breaks this. Because if someone went in here and started to say, well, you can default here, this is not expected behavior, that test should fail. So I think now is probably a good time for another break. This is sort of when the lecture should be ending, I think. I've got some more tests to write with you to do some asynchronous stuff. And so let's make this a quick 5-minute break. And I will start again on my clock. I think it says 11:37 is when I'll start. So it's 11:32 now. So let's start at 11:37 on my clock. All right. Seems like we have people coming back. Yeah, thanks for turning the videos on. To kind of gives me a good idea. At least a few people are back. Perfect. Okay. I think I should get started again. So when we left off, we'd written a single test, or 2 tests really. And actually, just so everyone knows, I've enabled the live share. So if you do want to follow along, apologies for not including that before. It's in the group chat for Zoom. All right, so we got these 2 tests. I feel like I'm pretty confident that they test the status component. And so my next approach is going to be this bug component here. And I think this looks pretty straightforward. Right? This component is pretty straightforward. And the purpose of this bug, or this bug component, is just to display the word bug on a button. And when that button is clicked, it clicks the onClick handler for us. So what we're really trying to do here is confirm that when this thing renders, it renders something called something with the text bug. So that'd just be our basic how should we render this thing, and we can see the test right here for that. Now we have to pass in something for the on click, maybe not. Like what happens if we just don't care about it? Test that out. And if these all pass, yeah, I'm quite happy. Actually, what I want to do is filter just to run only the bug test file. So I'm going to press W, and then I'm going to press filter P to filter by a file name. And then I'm going to type in bug.test, and I'm going to find it that way. So now it's only going to rerun the bug file for me over and over. Okay, good. So this test is passing, and we've done this already, so I'm not going to rewrite this code here. But is there any questions about what we've done? We've rendered the component. We gain access to a function that allows us to search the DOM for text. And then we can get that element that has that text and just confirm that it's in the document. So that's how we know this thing is rendering. There's this other test that I want to try, and it is that when we actually pass in an on-click function, we want it to call that function. Whatever that function has in it, that's sort of irrelevant because that gets defined by the user of the bug component. So I could have maybe something like this. It's bad token, so I just have to handler. There we go. So this is interesting. My test is failing right now after making this change. And what I passed to it was this function that calls bug click handler. And we can see it actually got called by the test. When the test gets run, the test call, somehow it calls this function, which console logs a bug click handler, which we see in the output. We can see here, this output comes from line 14. Where's line 14? Right here. Okay. But it's failing test, and that's because we expected the number of calls to this function to be 1, say, or we just expect it to have been called in the first place. So here it says we expect it to have been called, right? Greater than or equal to 1. That's how it's deciding that it's been called. But it's saying it's been called 0 times. And the reason why is because we've not sent a mock function. Happens to be the function we're checking here. So this mock function that we create on click, created with jest.fn, this function has the capabilities within it to keep track of how many times it gets called by something else. And so what we do is we create that mock function, we render our component, and we pass the mock function to it. And then when that function gets called, it keeps track of when it gets called. And so we can then check later with a matcher to see if that mock has been called. And we can even be very specific and say if the mock has been called a certain number of times. So let's be honest, that's pretty redundant, and the test is much better this way. Or not much better, but not vastly better, but not redundant. This checks both things. That checks what that other one did. Has it been called at all? Yes, it's been called 1 time. We can confirm that. And how did it get called? What do we think this does? Well, maybe, yeah, automatically pushes the button. Yeah, exactly. So it clicks the button. And the way it does that is through this fire event call. Fire event is something that gets returned or exported by the testing library. Actually, Fire event is not the React testing library. It is the DOM testing library because it's about firing a DOM event. The reason why it gets imported from React testing library is because the React testing library happens to also export all of those DOM testing APIs as well. So we're going to grab Fire element, which is a DOM testing library utility, and use it to trigger an event, a click event. And the thing that we want to click on can be found by getting an element with the text bug. Happens to be our bug button. If I run this with the debug, we're going to get some output before the button's clicked. And when it fires the event, it's going to find the element with the text bug, and it's going to click that element. It's going to fire a click event on that element. And that's what's going to cause our component here, when it gets clicked on, to call this function. This function gets called one time. And so we can expect that it's been called one time. Now, this test is passing. And if we switch this to 1, which should not be accurate anymore, because that function has been called 2 times now, because we've clicked the button 2 times, that's what we'll get, is that we expected it to be 1, but the actual value is 2. So we should fix that. And now we have a test that works again. So this is the introduction to mock functions. This mock function on click, it allows us to spy on this function and then assert that certain things are true about that function. It's very similar to in Storybook when you have your action and you want to show the action in the Storybook interface to confirm that the function gets called when you click on your component. It's a similar idea. We pass in this mock function or this kind of fake function, and then we can introspect it later to see things about it. So that's the bug component tested now. And if I move on to upgrades, I can start to think about the tests for this upgrade component. And so what I'm going to do is go over here, and I'm going to start to think about, I want to test the rendering of these elements. So I want to make sure that when I render the upgrades component with an upgrade in it, it actually renders that button with the right values. So I might do that first. It should render its children. That's these things. So I start off here by rendering the parent component upgrades, telling it there are 0 bugs, and then here the upgrade that we want to add. So that's going to be just one of these items in the list, only one item in this case. The improve item, it costs 1. And so from this, we can kind of say, well, that's what the text we'd expect to have, because that's how that component renders itself. So here, when we render this, we expect this element to be in the document. And if I do it this way, I can say, actually, I also maybe want to say, expect get by text improve to be disabled. Because that's actually something else that's important about this component here, is that when I'm rendering out these elements, if they cannot afford, so I have 0 bugs, but this one costs 1. If you can't afford it, then we expect that element to be disabled. And so here, if we say, you now have enough money to buy one, it shouldn't be disabled anymore. This test should fail. Oh no. I'm not sure why. Maybe I... No, that shouldn't pass. Oh no. Oh, okay, no, it should. Let's see. Found a bug, yay. No, I didn't. I expected that to fail. Okay, well, I'll look into that later. Um, I guess the point is, what I want to show you is that you can actually test other things as well. And we kind of have to look and see what is the reality here. When we don't have enough bugs, this should be disabled. So it might be useful to also test that at the same time. And I'll go debug that, and then I can post in the channel what was happening. But this was my main point, is that you might want to actually test a few different things, even if this one specifically isn't working for my case right here. Yeah, I don't know why. Okay, I don't want to get fixated on that. Now, here's an example of two different mocks being used in this component. Because what'll happen is when I click on, let's say that I actually use this interface, and I add some bugs, and when I click on, when I have enough bugs here and I click on this, I want it to increase the BPS by a certain amount. I want it to decrease the number of bugs by a certain amount. So the BPS, I want to increase it by this value whenever I click on it. And I need to make sure I have at least 2 in order to buy it. So I have 2 bugs here. When I click on the button, it should increase by 1, and this should decrease by 2. So we find the button improve 2. It's based on this cost and this label. We click that button. It's the upgrade button that we see right here. When we do that, we expect the increased BPS to have been called with the value 1. So now this is more specific. It's not that it's been called one time. It's been called with the value 1. And we could say expect, actually, if this was calling the same function, then we could check to see if it's been called 2 times, and then maybe with different arguments. These are different functions. So if it's been called at all with any argument, then it's also been called. So we don't need to have a redundant test for that or run an expectation for that. So here it'll just say, has this function been called with the value 1? Yes, hope that matches up. Oh, wait a second. It was a user error. So the issue with the upgrades was between my chair and my keyboard. If I go back up to this and do what I thought would fix it, would break it, I think this breaks it now. Good. I'm actually still able to code. The reason why this wasn't breaking before is because I was actually filtering the wrong test, and I was testing the bug one still, but now I'm on upgrades, and that's what I'm running. So I need to be more careful that I'm running the test for the file I'm working on. That's the danger of filtering. So that actually worked as expected, and now I'm actually running this test here. They're both passing, and the whole idea is that I think the main part of this is that I want you to see that all the pieces we need to determine sort of what this is going to do, it's kind of like an understanding of how this component works, and then its inputs specifically for this test. And we need to make these inputs work for the outputs. So the process of creating a test, the process of running a test is first set up your environment, then do the user actions, then check to see whether or not things are the way you expect them to be. That's sort of the 3 stages of a test, writing a test. Okay. So the last major one, and the last major topic I want to talk about before we, actually there's 2 things here before we finish up and start talking more generally about React. One of them is the asynchronous tests. So we have an asynchronous test because we need to wait for this loading indicator to go away before we continue checking to see if things are on our page or not. So we were able to test the status component just to see if it had this text on it, and we're able to test this bug component by testing to see if the text was there. But when it comes to testing the application itself, when the application loads, neither of those things are there yet. So we need to wait until they're there before we confirm that this stuff works together. So this is going to be our major integration test. And the first thing we want to do is render out our application. So if we do that, we're going to see exactly what it says. And I made that same mistake last time, so I'm gonna have to refilter now for application. When I run the application tests, I should see some output. It's right here. And this is telling me that when I output the debug, or when as soon as I render this component, it renders a loading indicator. And what I want to do is wait until this goes away, because when this goes away, then I know the app has loaded. It's the same way the user knows that the app is loaded, because the loading indicator has left the screen. We don't see it anymore. Okay, page must be loaded. So what we're going to do is we're going to wait for the element to be removed. So here we import this from the DOM testing library, or React testing library. It comes through that. We import some of this stuff right through the React testing library. So this one here, wait for element to be removed. And this is an asynchronous operation, so we want to wait until this promise resolves. And when it resolves, then the test is done. Then we're done the test. Then we know that the app is loading properly. And maybe we even go so far as to say expect get by text bug. To be in the document. When I run this, after it's done loading, then the bug button should be in the document. And that's still passing. So sometimes we need to wait for things to happen. And wait for element is a good example of wait for element to be removed is an already example of that. You can wait for generally kind of anything to happen. But the main thing here is that an asynchronous test must return a promise or have or call a done callback. So let's not even worry about done callbacks because we use promises here. And let's say that an asynchronous test must return a promise. Well, any function that has the async keyword in front of it, which you're going to get into today, you're going to actually start to use this to write your tests. Any function that starts with async in front of it, this function by default now, or by definition, returns a promise. That's how that works. So any test that returns a promise will not be expected to be completed until that promise is resolved or rejected, let's say. So we have to actually tell the test runner that this test isn't done until at least this promise is resolved, that this is completed. And that's important because there's a lot of timing stuff going on here. As we start to get into more complex testing, what we want to do is, does the auto fixer and the bug counter button, do they work in tandem? And if so, what does that test look like? And so here I'm doing this thing where I use some fake timers. I actually, instead of waiting for an element to be removed, I'm going to wait for something to show up instead. So this is two examples. I could do this instead. It would accomplish the same goal, but I want to show you multiple ways to do the same thing. I think that's probably something you want to see as well, because then it's less confusing if I just tell you now that these accomplish the same goal. One of them says I'm waiting for the text to go away, and the other one says I'm waiting for the text to show up. I'm waiting for the text to go away, or I'm waiting for the text to show up. Either way, so as long as we know that at this point, we can then click on the button. That's what that signifies. So only after we're done loading, then we can click on the button. If we click on it 4 times, then we should have the text, you have fixed 4 bugs, show up in the document. If we click it 5 more times, we expect that button console log to be disabled still. So that's 9 times total. Now we click it 1 more time, we expect it to not be disabled anymore. Then we click it again, and we expect it to say fixing 1 bug. Now here's where we have that act call. And the reason why we have act is because advanced timers changes the state of the component, and we need to make sure that that happens before we continue running our tests. So this is built into the testing library, and it allows us to include sort of any call that might change the state of a component. That call right here is a built-in Jest advanced timers. I mean, you can imagine if we've got an auto fixer that's fixing bugs every 1 second, it's really hard to work with tests and time, so we fake it all. And this is how we fake it in Jest, is we advance our fake timers by 1 second, and then we should see that one bug has been fixed. And then after that, advance by another second, and we should see that 2 bugs has been fixed. And then we click the button, immediately you should check to see that 3 bugs have been fixed. And then advance timers again and confirm, yeah, it's still adding correctly. So this is obviously a more complex test, but you can go in that direction and test all of that functionality, which is basically come in here, wait for it to load. 1, 2, 3, 4. It says 4 bugs. 1, 2, 3, 4, 5. This is disabled. Add 1, not disabled. Click. This is now fixing 1 per second. Wait for a second, check to see. Okay, now it's getting ahead of me because I'm not able to step the counter forward 1 second at a time myself. But the test is, and that's what these are for. Okay. All of this stuff that I showed you here is documented on the Jest website. And if I tried to teach all of this to you, I wouldn't be able to. And I think reading the Jest documentation is pretty pleasurable in terms of compared to some other stuff. So let's really go back to some of these things when you run into them. So for example, you don't need to learn timer mocks for what you're doing today. That is not necessary for anything that we're working on in the project today. So you don't need to learn all that advanced timer fake stuff. That's why I didn't really go through it in detail. But using matchers, this is really good to review. I need to match stuff in every test, no matter what. How they handle truthiness, the difference between 2 equal and 2b. 2b will just compare the value. 2 equal will compare all the values inside of an object. That's very different. What else? Mock functions. So this goes into a bit more detail about those mock functions that I showed you. You're going to be mocking Axios. So I'll show what that can look like. If I want to test that my get upgrades function returns the correct data after it's made its API request. This one is a set timeout, but let's say it makes an API request. Then I can write mocks that when someone calls get upgrades, it actually just returns this. I don't need to actually make the call anymore. There's no timers involved. This happens immediately. So in that case, in that case, I'm testing just the API here. With my API test, I say get upgrades, run the timers, and then I should expect the upgrades to come back. Like we can do a very similar thing with an API call, because the similarity between timers and an API call is that they both take a certain amount of time. They both take an undetermined amount of time. Like we don't know necessarily how long it's going to be. So that's what makes them asynchronous. I don't have any more details to show you. I guess there's some tests for these hooks here, which I won't get into, but they're tested very similarly to a component, except we use render hook here. We get a result. We can check to see on that result, we can call a function. That's the add bug function. And then we can check to see if it's changed the values for us. We can allow us to decrease. So same kind of thing, but add a bug, then remove it and check to see if it's 0. For the auto fixer, there's a whole bunch going on here. We got timers as well. So all this stuff is going to be available to you in the repo. The activities today are going to go through and talk and have you go through the process of doing all this. So that's where you're going to get most of your experience. I hope that this has been a good introduction to the testing. And I think that's probably a good place to leave it for questions. Hey, what was the act doing exactly? Yep. So let's go over that again because again, I didn't go into detail and you don't have to use it very much today. But act exists and is given to us by the React testing library. Let's see where I can find it. Here we go. So act is imported from the React testing library. If we go and look at the documentation for the React testing library, which is right here, the API, one of the 3 functions it actually owns is act. And it's so this is actually a wrapper around a tool provided by React. And it is so the reason why we want our React testing tools version to match our React version is because we have to use some of the testing utilities provided by React DOM specifically, including the act function. So this has to match the React implementation so that they actually work together. So if this function is provided by React, then and it's very React specific, then the way we can talk about it is when I need to do something that causes a set state inside of a component, for example, we know that doesn't happen immediately. So how long does it take for our component to update? We know set state doesn't happen immediately. So how long should we wait until we check to see if our component is updated or not? Mm-hmm. Right. Yeah. Like there's a whole bunch that could go on there. So it's an undetermined amount of time. And what ACT is doing is saying, wait until you've done that update and then continue the test. That's all this is doing for us. Is the test runner will say, okay, well, when I hit this, or like the React testing, when you call this, it means wait until React does an update before continuing. And the way that we're going to get React to do that update is by triggering the set timeout inside of the component. And then when the set timeout gets triggered, which is um, it's in this auto fixer thing here. So when the timeout occurs here, so when this timeout fires, it calls increment BPS. Increment BPS is a function that changes the state of the component, right? And when that's done, then we want to see whether or not the change happened or not. But we don't know how long it's going to take for React to do this part of it. So what ACT does is it tells the testing system to wait until that's done, to wait till increment has happened, to wait until the next basically wait for the next React render, and then continue. And that's when we can check to see if there's a bug or not. Because if we just did it this way, it would advance the timer, it would trigger that set state call immediately, but the update, the UI would still say you have not fixed any bugs because it hasn't had a chance to re-render yet. And by adding act, we make sure that it has a chance to re-render before it gets to this part here. Yep. It's just about making sure that you manage the asynchronous nature of your code in your tests, that you don't keep running like you can't check something until it's actually happened. And the way that happens, we know, is through a set state call. We know these set state calls are asynchronous in nature. So by wrapping in an act, we know that it will not advance our test until that set state has completed. I think that's the way I would probably try and explain it in a few sentences or a paragraph. Like I said, you're not using this a lot today. Honestly, you're not going to be using this a lot today. Well, it's not a force. It's not actually a forced render. It's a forced wait. So if you just call it and nothing changes the component, then chances are React will never let the thing continue, which means you'll just sit there waiting. Like I think if I take this out, I think it tells the testing to wait, but it never tells it to resume because it never actually Yeah. So as soon as I don't do the call that causes the update, it breaks everything because this says wait, and never unlocks. Yeah. It would only actually unlock when we do the thing that causes the component to re-render. Okay, now it's unlocked. It'll continue running the test. So this is like a lock until the update has occurred. Yeah, because React provides this function to us. This is actually a React function, so it's tightly integrated into the React library. So React knows that it should resolve this promise when it is finished rendering the component tree. No, it comes from the test utilities in React. So it's actually from this package here. It's from the test utilities package, which comes from React DOM test utilities, and it's only used for it's integrated into the test renderer, and the test renderer is used by the React testing library to render your components in tests. So all these things are built on top of each other. All these libraries that we're working with, React, Vue, Angular, they're all built on the DOM testing library, which are built on Jest and Jest DOM, which are built on Jest. So these also use the React testing library and React hooks testing library also happen to have a dependency on the test utilities library from React. I mean, that makes sense to me because the React testing library is tools that help us test React components in a way that allows us to follow our guiding principle. And so that guiding principle, but we shouldn't come up with new ways to render components. That should still be provided to us by the React library itself. And there might be equivalents for Angular and Vue that exist in the Angular and Vue testing library that allow you to wait until a Vue component has re-rendered until it continues the test. But that's mostly just about how do we handle asynchronous behavior inside of our tests, and that's where most of the complexity lies. So Act is really just about waiting for a React component to re-render, whereas things like wait for, that's waiting for an element or something to resolve. Wait for element to be removed. That's very specifically saying, I'm going to keep looking at the DOM, and if this element's there, I'm going to wait until it's gone before I can continue. The reason we don't have to use a wait before act, I think, this returns a promise, and I don't believe that act returns a promise. I think this actually suspends the I'm not sure about the details. I'd have to look at that. But just use it this way, and if you're testing a hook out, you'll see here I'm doing it because this also causes a change to the component that this hook is rendered in. When we call render hook, it renders the hook inside of a component. So this thing here, we need to wait for it to finish and re-render and rerun the hooks before we check to see if it changed the value or not. We can't do it right away because it's asynchronous in nature, those state changes. Any other questions?